All right, hi there. This is AGNR 131 Soil Science, and we are working on lab exercise number 10 today, which is soil microbial activity. Now, how we're going to measure that, there's lots of different ways to measure it. It's easier to measure it in the field. Unfortunately, we're not in the field. We're going to do it here in the lab. So what we've done is we got ourselves some mason jars. As you can see, we got ourselves some mason jars, and you can see that some of them have soil in them and some of them don't. So the way what we're going to measure here, first of all, let me explain exactly what we're doing. So we're measuring soil microbial activity. So what we're going to do with this is we're going to actually measure the respiration rate of the soil microbes, the soil microorganisms, as they ingest carbon-based materials from the soil. And there will be some in here. This was an old alfalfa field at one point. We've got some carbon in here as well. So what we're going to do is then we're going to see if the variable that we're going to test here is temperature. So we know that the microorganisms are going to consume whatever's in here, that carbon-wise. The soils are all the same, and they're going to actually respire. They're going to breathe out, if you will, and that's going to be carbon dioxide that they're breathing out. And if you remember from lecture, we have this exchange of carbon dioxide and oxygen between the soil atmosphere and the atmosphere that we're in. So we're going to actually measure that outpouring of carbon dioxide from the soil into the atmosphere by creating our own little microcosms here. So these are our own little worlds that we can actually control. So we can make sure that no carbon dioxide that gets generated in these little worlds actually gets a chance to escape. But for us to really be able to compare what's going on, we actually have to have some worlds that don't have any soil in them. So if we have an error, or we can generate some carbon dioxide because it's in the air, or maybe it's inside because there's something inside these jars, it's our source of error. So that's what these blank jars or these empty jars over here are. That they're still labeled, but they're not going to have any soil in them. What they are going to have in them is some sodium hydroxide, which we will put, and I'll show you this in a second, which we will put into these little vials, and we will actually then put those inside our microcosms, and then we'll seal them. The sodium hydroxide in here acts as a trap for the carbon dioxide. So what we can actually do then is whatever carbon dioxide escapes from the soil as a result of microbial respiration is going to be trapped in this sodium hydroxide solution here. We can then extract that, which we'll do in an upcoming week. We can extract that and measure the concentration of carbon dioxide in that. So a simple chemical reaction, measuring how much of it takes to actually cause the reaction, and then we'll be able to convert that into carbon dioxide amounts, and you'll be able to see that we can actually translate that not only into this little microcosm, but we could do it field level or whatever we wanted to. So it has some real practical, real world significance as well. Now, it's not just something that we're doing in the lab, but we can translate the results out into the larger world. Okay, so what we've done here, just to sort of catch you guys up, is that, as I said, and I need to go back to this, as I said, what we're going to measure is we know there's going to be some respiration. What we want to know is, will the respiration be affected by temperature? We could test other variables as well, but a simple one to test is temperature. So we've got 0 degrees, we've got room temperature here, and we've got 0 degrees Celsius, that's freezing, right? And then here we've got 40 degrees Celsius. Those of you who hate Celsius, that's about 104 degrees Fahrenheit. So nice hot day in the desert in the summertime. That's what we're looking for on this particular one. We're going to run 2 replicates. That's the minimum that we should be running for any kind of a science experiment, the absolute minimum. If we screw up on one, at least we'll have some data. And believe me, I've screwed up plenty on this particular experiment, so it's good to have it. The 0 degrees, we'll actually put that in the refrigerator. And the 40 degrees, we've got an oven over here that if we can get it calibrated just right, it'll sit right about 104, 105 degrees. But we'll measure that anyway. So we'll have a wide variety of different temperatures to compare. There'll be 3 temperatures, but it'll cover quite a range of temperatures from freezing to 104, 105 degrees Fahrenheit. So we've already got them all measured out. It's not critical that you put exactly the same amount of soil in it. What is critical is that you measure how much soil that you actually put in. But it's easier just to go ahead and put everything on a balance and get the exact same amount of soil in each one of your microcosms. So that's what we've done. This is what 150 grams of this soil looks like. So we've already done that. The next thing I'm going to do is I'm going to actually wet this down. I got a little pipette here, and I got some distilled water. Why am I using distilled water? Because I don't want to introduce anything that's tap water, anything that could be another variable. I don't want to introduce that. So I'm just going to go ahead. I'm going to try to be consistent here. I'm going to put 10 mils in each one of these things. What I want to do is I want to make sure that's not going to be enough. So I'm going to go ahead and add a little bit more. See if 20. These are really dry, these soils. So that's 20. And I'll mix these things up a little bit. I might even need a little bit more. I might even need more than that. So I'm going to put, I'll see what 30 looks like in this. I got more soil if I don't like what I've done. But so I will mix that up and see what that actually looks like. I want to get some moisture in there. I want to give these microbes the opportunity to be happy. They're going to sit in here for at least a week before I do anything. So I want their environment not to be dry, but to be somewhat moist, so that they can actually be happy, and whatever living that they choose to do, it won't be limited by the fact that their soils are bone dry. So that's 30 in there. I don't think that's enough. I'm going to probably add a little bit more, but what I'll end up doing is I will add the exact same amount to each one of these microcosms, and then when I get all this added, then I'll come back and I'll put in the sodium traps, or the carbon dioxide traps, the sodium hydroxide that's going to act as a carbon dioxide trap. I'll put those in there, and we'll get those set up, and you can see what that looks like. So we'll be right back. Okay, so what we finally found out was best was for these soils, they were pretty dry. We put in 25 mils of water, distilled water, in each one of them. That seemed to be perfect. We could mix it all up. The soil was obviously a nice damp consistency. We could have probably squeezed it together just barely in our hands. It probably would have quite crumbled. So we want to get these things sealed up pretty quick before they dry out. What I'm going to do now, we've graduated to a proper size pipette. We had the wrong one before. We're going to put in, this is I'll put my glasses on here just to be safe. This is sodium hydroxide, 1 molar sodium hydroxide. So I'm going to go ahead and fill this thing up. We need to put 14 in there, 14 mils in each one of those. And I'll just go ahead and just do the one here. And it's just kind of show you what's going on and what we're going to do. So there's my one. So I'm going to carefully stick it inside this and go ahead and just dispense it in there. I'm just going to dispense it slowly. Okay, so that's 10. I don't have a big enough pipette, so I'm going to do another 4 in here. It's going to be right to there. All right, I'll put that in. Okay, so now what we're going to do is, that's just one. So now what we're going to do is we're going to go ahead. There's no soil around the outside edges of these. We've been very careful. We've got no other real source of contamination. These mason jar lids, the lids are good. I'm going to seal them on. They're pretty tight like that. They should be. I mean, yes, it could fall over, but I'm going to assume that it's not going to fall over. And there we have one microcosm ready to go. So I'm going to do the same thing with the others. I'm going to do the same ones with the controls here. So then we're going to go ahead and put the room temperature. We're just going to put over here on the bench out of the way, someplace safe, they don't get knocked over. And the room temperature in here is probably, I'm going to guess that we have a thermometer someplace. Around 72, 74 degrees is probably what it's going to stay in here, because it's kind of climate controlled. And then we'll put the other one in the refrigerator. It may not be exactly 0, but we'll go ahead and put a thermometer in there and figure it out. And we're still trying to get our 40 degrees Celsius or 104, 105 degrees Fahrenheit dialed in on our ovens. It's kind of a low temperature, but we'll figure it out. But we'll get whatever that temperature is, and then we'll get back to you guys with what that is. So we actually have all the numbers, and everything is going to be consistent. So I'm going to go ahead and leave it at that. I've kind of explained what's going on. Remember, now we've got the sodium hydroxide inside that little centrifuge tube is going to act as a carbon dioxide trap. These little microbes, microorganisms, they should be starting to do their stuff. We've given them moisture in that dry soil. they've got adequate moisture, they've got food stocks available. They should be beginning to do a little bit of multiplying of their colonies, like sort of building up their stuff, getting excited about the fact that they've got some nice conditions going on through there, and begin to produce carbon dioxide. Now, and we'll see if putting them in different temperatures is going to make a difference in how much carbon dioxide they actually produce. So that's the experiment. We'll come back and we'll come back in a week or 2 weeks, depending on what our time frame is. At least a week, and then we'll go ahead and measure these and give you guys the data, the results. So we'll see you in a week.